Hello everyone. Here is one more problem on psychrometry. This is little bit more added to the previous problems. So let us see the problem. The problem statement is 0.004 kg of water vapor per kg of atmospheric air is removed and temperature after removing of water vapor becomes 20 degrees centigrade. Determine number 1 relative humidity, number 2 dew point temperature. Assume that condition of atmospheric air is 30 degrees centigrade and 55% of relative humidity and pressure is 1.0132 bar. So here first we have to understand the problem before we proceed to the solution. So what is the problem statement? It is saying that initially the condition of the atmospheric air is 30 degrees centigrade and 55% relative humidity. Okay, so initially let us take a sample of air whose temperature is 30 degrees centigrade and relative humidity is 55%. dBT is 30 degrees centigrade. Now 0.04 kg of water vapor is removed from this air. From this air 0.004 kg of water vapor is removed. Water vapor removed. So then after that what happened, temperature from 30 degrees centigrade and after removing, and it is cooled because the 30 degrees temperature is reduced to 20 degrees centigrade. So finally temperature is 20 degrees centigrade. Now you are required to calculate what is the relative humidity as well as dew point temperature. So 0.004 kg of water vapor is removed and it is cooled from 30 degrees centigrade to 20 degrees centigrade. As a result of this, what is the final relative humidity and what is the final dew point temperature you need to calculate. So that is the problem. First let us see the data given. Initially dry bulb temperature is 30 degrees centigrade. RH relative humidity phi1 is equal to 55%. And what is the pressure given? Atmospheric pressure or barometric pressure is given as 1.0132 bar, right? So from this 0.004 kg 0.004 kg of water vapor removed. So it is to be calculated the relative humidity phi. So what is relative humidity? The definition for relative humidity, this phi 2, let us say this is phi 2. Phi 2 is to be calculated. Phi 1 is given as 55%. Phi 2 is to be calculated. So whatever may be the relative humidity phi 1 or phi 2, formula is Pw by Ps. What is phi? Relative humidity is equal to Pw. Pw means this is partial pressure of water vapor divided by Ps. Ps means saturation pressure or saturated pressure of water vapor at that temperature. So before we get the value of Pw, how to get the value of Pw? It is not given here. Partial pressure of water vapor is not given here. So first let us see what is the specific humidity, because from specific humidity we will get the value of partial pressure of water vapor. So from that we will get the second condition parameters. So first let us calculate the partial pressure of water vapor from the relative humidity given here. So phi 1 is equal to Pw1 by Ps1. Let me call this as Pw1 by Ps1. Okay, so what is Pw1? Partial pressure of water vapor. We don't know that. Then what is Ps1? Ps1 value, it is it can be taken from the steam tables at 30 degrees centigrade. So from steam tables at 30 degrees centigrade, from steam tables, Psat or PS1. In this problem it is PS1. P sat is equal to PS1. It can be taken from steam tables, and that value is equal to 0.0425 bar. Please refer the steam tables. Beside 30 degrees centigrade, you can see this value 0.0425 bar. Okay, so we know phi 1. What is the phi 1 value? 0.55. It is equal to PW1. We don't know, that we are going to calculate, divided by P sat 0.0425. From this PW1, partial pressure of water vapor, it is calculated as 0.02337 bar. Okay, so we have got the value of partial pressure of water vapor at condition 1. Now using this partial pressure of water vapor at condition 1, we are going to calculate the specific humidity at condition 1, that is W1 is equal to, already we know the formula, 0.622 into partial pressure of water vapor divided by P minus PW1, partial pressure of water vapor again. So this is equal to 0.622. PW1 we have calculated it as 0.02337 divided by 1.0132 minus 0.02337. Okay, if you calculate this, you will get the answer as 0.01468 kg of vapor per kg of dry air, per kg of dry air, right? So this is the specific humidity initially. 0.01468 water vapor, kg of water vapor is present in 1 kg of the dry air, right? Now what is the amount of water vapor removed? That is 0.004 amount of water vapor is removed. Now W2, or specific humidity after removing water vapor or water vapor, that is W2, which is equal to W1 minus 0.004 is removed, right? Therefore W1 is given as, or calculated as, 0.01468 minus 0.004. This is equal to, what is the value we are going to get with this? That is 0.01068 kg of vapor per kg of dry air, kg of vapor per kg of dry air. So specific humidity at condition 2, we are able to get the value, specific humidity at condition 2. So with this specific humidity at condition 2, we will see the remaining parameters, how to get the remaining parameters we see. And at condition 2, what is the dry bulb temperature given? At condition 2, dBT or TdB2 is given as 20 degrees centigrade. In the problem statement, it is given as 20 degrees centigrade. So what you have to do is, partial pressure of water vapor, let us calculate with W2. So W2 is equal to 0.622 into PW2 by P minus PW2. So W2 just now we have obtained it as what is that value? 0.01068 is equal to 0.622 PW2 by 1.0132 minus PW2. So from this expression, from this above expression, we will get the value of PW2, which is equal to 0.01068 0.0171 bar. Okay, PW2 we have obtained, right? Now from this we can calculate the relative humidity. For that we need to know PS2 also. So from steam tables at 20 degrees centigrade, P saturation or PS2, in this problem it is PS2, that is obtained as 0.0234 bar. Now what is phi 2? It is equal to PW2 by PS2. PW2 just now we have calculated it as 0.0171 bar divided by what is PS2? Just now it is obtained from the steam tables as 0.0234, which is equal to approximately its value is 0.73, or this can be written as 73%. Okay, relative humidity at condition 2 is calculated. And what next? Second is, this is the first one. What is the second one? Dew point temperature, DPT, dew point temperature. What is dew point temperature? It is the saturation temperature, it is the saturation temperature corresponding to PW2. Okay, so from steam tables again at 0.0171, because PW2 is 0.0171 bar, from steam tables at 0.0171 bar, T sat is equal to, if this is not obtained directly, please go for the interpolation, 15 degrees centigrade. This is the second answer which we require. So it is simple, but what you have to remember is the formula wherever it is appropriately to be used, and second is the taking readings or values from steam tables. Okay, so I hope it is clear. Let us meet in the next problem. Thank you.